Well, good morning and welcome to Heart and Vascular Center Grand Rounds, and welcome to the DeBakey CV Live Studios. It's an overused word to say it's a great privilege to introduce somebody, but that certainly applies to my guest today, and that is Dr. Peter Schneider. Dr. Schneider did his MD degree at Johns Hopkins and then traversed across the country to UCSF, where he did his general surgery and his vascular surgery training. And he practiced there for many years before going off to Hawaii. And he started the vascular program for Kaiser Permanente in Hawaii. And that's what he's speaking to us at the moment. So I'm not sure whether Peter went to bed early to get up to give this presentation at 3 a.m. Hawaii time, or he's going to go to bed late. That's basically, he'll tell us a little bit about that. Peter is a very distinguished academic vascular surgeon with numerous papers, publications, and wrote a really landmark textbook on endovascular skills, which I recommend to all of you who are beginning in the endovascular training paradigm. But what we're asking him to talk about today is really his entrepreneurial activities. And because of that reason, he splits his time between Honolulu and UCSF, which of course is the hub really of a lot of the great entrepreneurs and some of the startup companies. And so Peter had really started and exited several startup companies, has numerous patents. So instead of talking about just a regular vascular surgery topic today, I thought this topic would be germane for all of us in the Heart and Vascular Center. And Peter's going to talk to us really about taking this concept and building a company. And I can think of no one better, at least in the vascular surgery world, to address that than Dr. Peter Schneider. So Peter, educate us.
Thank you, Alan. Real pleasure. Thank you so much for inviting me. And I think when we first talked about this, we were hoping to visit in person. No one could have imagined that the world would be at a standstill for a period of time, but nevertheless, it doesn't prevent us from getting together this way, and I'm honored to have the invitation. I have to say I did get a chance to meet Dr. DeBakey in person early in my career, and it's a pleasure to be with you at Methodist. So let me just jump in to this kind of concept of concept to company. These are my disclosures. I work as a consultant for several companies, but I don't have employment within industry. Anyways, there are a lot of, I'll just go through some of the different thoughts that I had as I was embarking on this journey. I've had a lot of fun with it. I'm a clinician. Most of us have ideas. We work in these highly complex, highly technical areas. And very often, I'm imagining any of us could be, oh, I wish I had a clamp that did this or a catheter that does that. And yet, how do you get from that point, even if it's an amazing idea, it doesn't develop itself. It takes time, it takes energy, it takes resources. And over these past few years, I've had a chance to kind of try to understand that process. And that's what I'm going to talk about today. So this is, if you look out there, you'll see a lot of different sort of definitions for innovation. This is one of the ones I like the best: executing new ideas to create value, from a business school professor in Australia. Well, what makes me qualified to talk about this topic? Well, firstly, to be fair, I'm sure there are people that are more qualified in terms of developing concepts and that sort of thing. But I think the thing for me is that I am a clinician. My primary job is not developing things. I have always valued and been better at taking care of patients. But I am fascinated with ideas and with the developmental process, and ended up starting 3 or 4 companies at my dining table, depending on how you count them. It's been an amazing adventure. The other thing that makes me qualified is I've made maybe every mistake you can make. There are probably more that I haven't thought of making yet. But actually, the way I got into this was back in the mid 2000s. I was doing a lot of work within my medical group. It was about a 650 doctor medical group, doing a lot of work on the administrative side, on the administrative side for the group, a lot of extra hours, mostly unpaid hours. Just, I wanted to see our group succeed. And when we had a new administration come in 2007, basically I was fired. They decided they didn't want me to help. They wanted someone else. So needless to say, after putting an awful lot of time and energy in, I was really irritated. And I came home and I was, in that frustration. My wife says to me, "You're always talking about your ideas. If you weren't spending so much time doing this other thing, you could be working on your ideas." And so there I was, immediately confronted with this concept that if you want to actually develop an idea, you have to devote the time to it. So, in my reading and in my sort of journey, if you will, I've come across several interesting sources, and I want to share some of them with you. One of them is called The Rational Optimist. It's a book by Matt Ridley. I've recommended this book to many, many people. And the premise of the book is I want to be optimistic, but everyone is telling me the world is going to hell. And if you go through if you dig into the book, there are statements like this: today, of Americans officially designated as poor, 99% have electricity, running water, flush toilets, et cetera, et cetera, et cetera. He goes down the list. He says Cornelius Vanderbilt, the richest man in the world in the 1800s, had none of these. And it just strikes me how innovation has changed our lives. Another one, and this is one of the more favorite books I've had in the past 10 years, and this is called Sapiens. Many of you, I'm sure, have read it. It was very popular a couple years ago. But he talks about Neanderthals, and Neanderthals, which we tend to denigrate at this point. Nobody really knows personally a Neanderthal. It was a separate species. It didn't pre-exist. It didn't exist before us. It coexisted with early Homo sapiens. It intermarried. The group intermarried and eventually disappeared. But it turns out, when they study the Neanderthals, what they find is that people who were quite physically capable, quite mentally capable, except that they were less capable of abstract thought and innovation. I think about innovation as something that defines us. Yet again, here's another one that talks about innovation from a slightly earlier time frame. And the message there is that for, over hundreds, if not thousands of years, the societies that are more open to innovation are the ones that are able to survive better than the ones who resist innovation. So I would just say that among our mission as physicians and as people who take care of patients, quality service and stewardship are a given, but I think we also have an obligation to innovate. And I'm not talking about new devices necessarily, but I am talking about taking a look at our environment and see how it can work better. So let me just dig into this concept of the developmental process. So each project, in my opinion, takes on a life of its own. And you have to ask, is there an unmet need? What problem am I solving? Is there a market opportunity? Can the intellectual property be protected? And I sort of look at each of these projects, each developmental task or effort, each, if any of you have kids, each kid is a startup. And each kid has different needs at different times, lots of needs, but different needs at different times. And that's kind of how a startup is. And then again, what is the value proposition? Can you put that value proposition into a couple of sentences? That is known as an elevator pitch. And that's something that would get your point across in a very short period of time, because sometimes that's all you have is a very short period of time. And how about this? Once you kind of go through the initial exercise, what about a prototype? How would I prove proof of concept? GLP preclinical studies, first in human, and then other things that you need lots of good engineering help for, like with manufacturing, validation testing, and of course, clinical trialing is another whole skill, and the regulatory process. So it's a certain pathway. Each one has its own idiosyncrasies. But the other thing you might ask up front is, what's the scope of your idea? Is it a product Is it just a device, or is it potentially a company? So, and let me explain what I mean. So if you think of W.L. Gore and you think of what we use, we have Viabond and we have PTFE covered balloon expandable stents, but they make PTFE covered everything. We just know about the medical products. They wrap different types of wires, industrial grade wires. They make garments, et cetera, and they do all that with PTFE. So PTFE, instead of just a product or device, it becomes a platform, if you will. The other ways that the scope of your idea could be assessed is, is it a cool gadget that's just looking for the killer app? Or is it a better mousetrap that is an iterative improvement on something we already have? And is it so much a better mousetrap that it could be a market leader potentially? That is, to show up with yes, it's an iterative improvement, but it's such an improvement that it might optimize treatment within an established array of products. And then lastly, I would put this at the top of the heap, is it actually a platform change? So think about landlines to cellular or coaxial to monorail. I mean, we still use coaxial, but it's hard to imagine coronary interventions without the invention of monorail. Is it a transfer of existing technology or a needs-based invention? And so by that, what I mean is there is a tremendous amount of existing technology out there that's just waiting to be transferred to humans. Some of it already is. Let me just remind you that we practice an inexact science. Almost everywhere you look, we're doing things to make up for the fact that we don't know or understand each patient individually. So we have population management, treatment guidelines, et cetera, et cetera. Eventually, we'll have specific treatment plans for each patient, and some of that's going to come from existing technology. On the other hand, you have the concept of needs-based innovation, and this has been popularized by the Stanford Biodesign Center. One of the people I know is a fellow named Josh Mackauer, who's been quite involved there, and he's got a publication there that I've referenced. And he's also a physician, and he was one of the folks that came up with the sinuplasty balloon for the application of angioplasty to the sinuses. But nevertheless, needs-based innovation starts with the need itself. That is to identify, so characterize major problems and perform intensive observation, invent, brainstorm around possible solutions, and then implement, test, and de-risk the possible solutions. One other thing just worth mentioning briefly is this concept of the innovator's dilemma. So this was written several years back by Clayton Christensen, who's a Harvard Business School professor, and he coined the term disruptive technology, which of course now is it's an, in a way, overused term, but the way he described it was it's something that disrupts the status quo. It's new technology that, quotes, unexpectedly displaces the established one, although very frequently we look back and we say, well, of course we needed that. It very often looks initially like a bad idea, but it serves a segment of the market that was previously ignored. And if you think about disruptive technology, it has the possibility to leapfrog other technologies, whereas if you look at the performance of any device or product over time, most of the changes we make are along this line, that is sustaining technology. These are iterative changes that help improve what we're doing. And so investments in those make it difficult to change course to a so-called disruptive technology. So in assessing the unmet need, how big is the problem? Do people even realize that it's a problem? Like, how did we know we needed Post-it notes, for example? How many people would be helped by it? You could have the most amazing thing ever, but if it only is going to affect or influence the lives of a couple of people, is it really a problem worth going after, given the time, cost, and effort of this type of problem solving? And what is the pain point? So in other words, you may have a solution, but people may not want it. Maybe the inconvenience of the workaround of the old method is not so bad. So one of the people who are famous for sort of putting out a certain point of view was Steve Jobs. and this is a direct quote from him, people don't know what they want until you show it to them. That's why I never rely on market research. Our task is to read things that are not yet on the page. Well, I'll just say not everyone is Steve Jobs. He was clearly a very unique individual. I can recommend this book to you, however, which was quite interesting. And of course, he had that ability to see further ahead than most people, but it also somehow convinced him, this is just my own personal opinion, it somehow convinced him that he had more control than he really did. And he tried to work his way through a cystadenocarcinoma of the pancreas without the medical attention that I, in my naive state, would have gone and gotten. And that's ultimately what took his life. So the next issue is, what is the value proposition? How will this endeavor, this catheter you want to make, this thing you want to build, how does it create value? Can I get it down to a sentence or two? That's my elevator pitch. And is there a strategic advantage? So in other words, everything that most of us work on a day-by-day basis, even important innovations, are things that will ultimately be replaced fairly quickly by other people's ideas, or maybe by a subsequent idea that we may have, because we're constantly looking for ways to make improvements. But once in a while, something comes that has a tremendous strategic advantage, and that is what is that makes it sustainable. So sustainability is where you look when you're trying to assess strategic advantage. So think of the iPhone. The amazing thing about the iPhone is, obviously it's not just a phone, it does a lot of other stuff, but it's interconnected with everything else you do and all of your other information outlets, including your computers and everything else. And that interconnectivity is a tremendous strategic advantage, and that's going to make it sustainable for quite some time. And another example of sustainability, if you think of the Roman Empire, how did it last 500 years? Well, they built roads and they built aqueducts everywhere they went. Roads so their armies could get there, aqueducts so that the villages would be nourished and agriculture could grow and their army could be sustained. And so if you think about this as an early example of a strategic advantage, obviously kind of a dramatic one. If you ever get a chance to visit Europe, everywhere you look and everywhere you go, there are roads and aqueducts built by the Romans. What about intellectual property? So for most of us doctor types, we may have an idea. The first place we often think of is not, can I build this? It's, can I protect it? Because we're all full of lots of ideas all the time. But I have to say, an idea is only the first of many, many steps. And I'll show you some of those steps, or at least through my experience. But talking to a patent lawyer is like a sit down with Dr. Spock for $1,000 an hour. They don't really speak the same language that we do. But if I could narrow it down for you, the claims, that is the specific claims in the patent that you want, is that the features that make your idea work have to be in the patent. Those are the desirable claims. And intellectual property in a crowded space, like a nitinol scaffold in a blood vessel, that can take 3 years easily, or even a little bit more than 3 years, depending on how you do it. The other couple of interesting things is they have a thing called prior art. That is anything that's been published in any previous patent, but also almost any previous production of anything in a magazine or on the web in some way. And your invention has to be not revealed. It has to be not previously seen in that so-called prior art. And the patent examiner has to decide that your invention is non-obvious. So if the milk carton hadn't been invented and you wanted to invent the milk carton, the patent examiner may say, well, we've always known about milk and we've always known about things to put milk in. Therefore, your invention is obvious. And your invention to get a patent has to be non-obvious. And so this is just a very interesting sort of way of thinking about it. And a smart investor might ask, what is your best patent? And then I'll just say that, again, from a physician point of view, my sense is that if you're too secretive, that is, that you hold your idea so close to your chest because you're afraid that you don't want to reveal it to anyone else, it will sit in your desk drawer. You have to move beyond that. Although I do think somewhere on the other end of it, it's a mistake to go to a major strategic company without an application for intellectual property. So somewhere in between those two extremes is probably the best path. And by way of example of patenting what actually makes your device work, I picked some famous examples from history where there was already a patent. For example, the steam engine, the elevator, the light bulb. With the elevator, for example, the Otis elevator, Egyptians used elevators to build the pyramid. It was the safety brake from Otis that was patented and actually puts his name on a lot of elevators you're going to get on in your daily life. The light bulb, there was already a patent for the light bulb, but Thomas Edison did he figured out the right filament, a carbon-coated thread that would last many hours longer than what previously existed and made it commercially viable. And another example is the Wright brothers. There were airplanes already, but they added an engine and they added controls, which of course we benefit from greatly today. And I'll just say this is also an excellent book, which I highly recommend. Another thing that comes up that people will ask about is something called freedom to operate. Now, freedom to operate essentially means that you have the ability to make your device in peace without being, blindsided or molested by another party. And it really is about assertive intellectual property. So you have to be both offensive and defensive. And one of the ways you create a defense is to create a barrier of entry, by other folks who may want to play in the same field, by a family of patents. And so imagine if someone built your device anyway, what would that patent look like that they would need? Well, patent that. Even though you're not necessarily going to build the device that way, you also need freedom to operate at some point. And you do want non-infringement. That is, you want your patents not to overlap with anyone else's. And you also have to recognize that it's a layered international process, that the US market, while being important, is far from, and less importantly so, as a market in the world. And in fact, if your device is really a tremendous advantage or tremendous advance, you would want it to have the opportunity to be used in other countries. The R&D process, I would say pick the cheapest route to proof of concept. Because if your idea is a bad one, the sooner you find out the absolute best for you, your family, and everyone else around you. Preclinical studies can be done to help decide proof of concept, and there are lots of new ways. You don't have to immediately go to the animal lab. There are all kinds of modeling, finite element analysis, cadaver studies, et cetera, that might help you before you get to the animal lab. And then you need to proceed to prototyping. And ultimately, your prototype, even if it works early on in its unrefined state, ultimately, whatever you thought of has to be manufacturable. The cost of goods, the cost to make your device, if it outweighs the cost that people are willing to try to solve that problem, then it may not be of use. So honestly, this was my most fun part of the whole process after the idea, in the sense that I felt like I had a lot to contribute here. As your idea hopefully gets more sophisticated along the pathway, you need lots and lots of experts to help you, whether it's through the more sophisticated manufacturing process or the regulatory process, things that true experts live their daily life doing. There's no possible way you're going to be as smart as all those people, and you're going to need lots of help, just like I did. This is a book that helps me has helped me in my daily life, but I apply it to this inventing process. And this is a book called The One Thing by Gary Keller. He's really a real estate guy, but this is a sort of a way of thinking about your daily life. And he asks this question. This is what he does in the book, and he helps you sort through it. What's the one thing I can do such that by doing it, everything else will be easier or unnecessary? And this is a question that if you ask it frequently in this developmental process, it'll most likely help you quite a bit. So what about first in human trials? Well, these are small feasibility trials. Obviously, a lot has to happen before you get to that point, especially with regards to proving to yourself as a physician that the device or idea that you're going to use is really ready for prime time. And of course, each country that might be considered for a first in human trial has its own controls and its own regulatory establishment that must be met. But these are small feasibility trials. These are rare to be done in the United States. I think it's because of our medical legal environment and other things. But I've only been involved in one first in man in my entire career out of, maybe more than a dozen different opportunities that was in the United States. The rest are all outside. And there are rules around shipping non-FDA approved devices. So if your device is made in the United States, you want to use it outside and yet it's not approved in the United States, there are stringent rules around that you need to look into. And almost always a first in human trial leads to a modification of the device. You have to go into a trial not saying, well, is it going to work? You have to pretty much know already that it's going to work. I would go, usually the question is, how will what we learn tell us how the device can be better? And a first in human trial can be used to design and to power a pivotal trial, which is extremely helpful. So who are the players in this amazing opportunity that you may have to help develop your idea, or maybe you're going to help someone else develop their idea? Well, there are all kinds of people, like I said, who live their daily life in the effort to make this happen. And of course, if in the practice of medicine, you meet some of the smartest people ever, both those practicing medicine and also our patients. And I learned things from a lot of different people. Well, getting a look under the hood of this area has been one of the most fascinating things. The engineers and the corporate attorneys are as different as orthopedists and general practitioners in our field. So, for example, an engineer, typically they're natural born problem solvers. The business person who's willing to take on the role of a CEO or a high sort of a board or high position in a startup, that business person, that's the type of person that when they get to Magic Mountain, they go on the upside down 360-degree roller coaster on their first ride. And I'm saying, well, wait a minute, won't that exacerbate my radiculopathy? And these are people who live their lives like that. It's just one up after one down. The patent attorneys I already mentioned, they speak a totally different language. The corporate attorneys, whereas the engineers are problem solvers, the corporate attorneys are problem finders. I mean, they live their life looking under every rock, and they are looking to protect you from yourself. And I have to say, I've learned this the hard way. And you can imagine how each of these folks would have a sort of a different approach, a different ethos. And it's really, really, really rare, in my opinion, when one person comes up with an idea and has the skills to see the whole thing through. I think almost always you're relying on the fact that you're going to find really good people to help you. Each company has a life cycle. So as I mentioned, each of your kids is a startup, and there are different phases that each kid goes through. Well, the life cycle of a company, the initial one, the startup phase, the one I enjoy the most, it requires seed money. It's usually a couple people, and everyone involved is wearing multiple hats. Then there's this thing that's been aptly termed the valley of death, where most startups fail. And that is because they run out of cash. They haven't proven their idea to the point where others would believe it strongly enough to support it. And then there are more sophisticated iterations of the startup, the A round company and the B or C round company that's in various stages of approvals, possibly even commercializing their device. So, and I'll just borrow a quote here from Steve Ballmer, who obviously is a brilliant person, But his take, the Microsoft CEO in 2007, was there's no chance that the iPhone is going to get any significant market share. No chance. And of course, so what I mean by putting this here is just to tell you that no matter how amazing your idea is, there are going to be folks who they don't see it. And you can't hold that against them. So how do you get financing? And financing, in my opinion, is sort of, we're mostly in the audience, blood supply doctors, heart and vascular blood supply. But financing is blood supply for ideas. And the sources of financing, typically people start with family, friends, or angel groups in their local communities to get seed money. If you can get grants, that's even better because that's typically non-dilutive seed money. But then as you kind of move up the ladder of opportunities, there are family offices or high net worth individuals that are interested in investing in these kind of things. There are investment funds and venture capital companies that look specifically. I always laugh at this concept of vulture capital. This is what Newt Gingrich called Mitt Romney when they were running against each other in the election, 3 elections ago, because Romney had been at Bain Capital. But the truth is that it's a true profession to be able to marshal the resources and marshal the finances to support an idea as it's growing. And the strategic companies, especially the larger ones, might take a stake in your venture, but they're limited in how much they can take. And the venture arms of large companies, foundations, et cetera, also set aside usually a few percent of their money so that they can invest in what they would call very high risk ventures that may ultimately see fruition. And then there's private equity. Private equity is very interesting because they're usually looking for companies with existing revenues who just may not have found their sweet spot. And they frequently talk about a quotes turnaround, so it could be a good idea that's just failing because it doesn't have the right resources around it. So I've never been in that zone of that, needing that, although I have done some due diligence for some private equity firms. So I've gotten a look under the hood. But in any event, is the finance scalable? Are the milestones reachable? There may be multiple rounds required. When a venture capitalist looks at your idea and says, oh, well, geez, maybe I could support it with X amount. In his mind or her mind, they're thinking, well, geez, 5 years from now, they're going to need 4 times that much. Now, how are we going to come up with that much so the idea doesn't die before it's ready for prime time? So the whole thing feels like this. Again, if you have kids, you've played this game, Chutes and Ladders, where you can go, if you draw the wrong ticket, you can go from number 87 to number 24. And that's kind of how you feel. You feel a little bit like the rug got pulled out from under you if you had or were counting on financing and it doesn't come through, et cetera. So, and then of course, who has control of the company? And it very frequently comes back to who's put over half the funds, the dynamics of the board of directors. If it's a friendly group working together, it's so much better. But as the company grows, the motivations of the different participants, they might be well aligned, but very often they're not. The founder may want out, or the founder may envision a worldwide takeover, whereas the folks that put in the money want their money back. The folks who've been running the company for several years, working essentially 3 full-time jobs as they're doing it to make the company work, they maybe are exhausted and they want out. So it's a real, you just don't want it to be this. And I don't know if any of you have seen the first season of Succession, but you can see Cain and Abel fighting on the painting in the background there. You just don't want it to be that. In any event, what about the investor mindset? The investor mindset really changes depending on which investor group you're talking to. I do think it's smart to get other people involved. Don't try to spend your own money to develop something, almost no matter how small it is, because it's going to cost so much more than you imagine up front. It's good to put a little bit of your own in, if some of your own in as a seed money type situation, but you have to know that you're going to need people to help you if it's an invention that's going to help other people. So angel investors tend to want to invest in the community. the family offices very often are altruistic. They've accumulated some money. They want to invest in devices or ideas that are going to help make patients better. The strategic companies would like to have a seat at the table. They have fear of missing out. They might want right of first refusal on your idea because maybe they think it's a good idea, but they just don't know if you can execute. The venture funds typically have a sweet spot. So, for example, it doesn't make any sense for them, for some of them, to put in a very tiny amount of money. $1 million or $2 million might be tiny to them if they have tens of millions or hundreds of millions. And yet they have to do the same amount of due diligence on you and your idea and your project as they would for something where they were deploying much more money. So they typically have a sweet spot amount. They have content comfort levels. So there are some that really are more comfortable, say, in digital health, and some that are more comfortable in around dialysis and kidney problems, et cetera. And the developmental stage of the company is also something that venture funds really look out for. Some of them really do not want companies that are at the very beginning. They want at least some of the risks to be taken away, a so-called de-risking of the company. And then again, life cycle awareness. It could take 10 years. The initial round is the smallest. And here's just another quote for you to keep in mind if you are rebuffed when you present your idea to someone. And here's Alexander Graham Bell trying to sell the telephone to the president of Western Union. The telephone has too many shortcomings to be seriously considered as a means of communication. So even the smart people get it wrong. Let's talk about the FDA for just a few minutes, because we are in a heavily regulated industry. We might be as heavily regulated, maybe more so than the nuclear industry. The device classifications, type 1, 2, and 3. Typically in the medical field, we're talking about type 2 and type 3. Type 2 would typically go through with a so-called 510K pre-market notification. And type 3, a high risk, think of an implantable, a stent, a pacemaker, a total joint, et cetera. They go through with a PMA, a so-called pre-market approval. And that's the ones where you need to do a pivotal trial, very often the same treatment as pharmaceuticals. And if you look at that process, which has been delineated here, what you see is the average cost of some of these steps. So just looking at the steps here, so this is after you've got your idea, you've proven the concept, maybe you've done first in human, et cetera. A feasibility study, 10 million average cost, pivotal trial, 66 million average, PMA approval, 2.5, post-approval study, a little over 4 million. So you can see that this is not for the faint of heart in terms of what it takes to potentially develop something. So what does the FDA regulate? Well, almost not everything you look at, but an awful lot of things, from foods and drugs and dietary supplements, devices, electronic products, cosmetics, 25% of the US economy. The group that typically we get involved with is the CDRH, the Center for Devices and Radiological Health. It's about 10% of the FDA budget, and the FDA budget in 2019 was $5.7 billion. The CDRH has about 1,500 employees, and they have a mission to protect the public good. And your device has to conform to that. So the 510K process that I mentioned, it does require a predicate. That is something that has gone before it, that we can say has substantial equivalence. It takes 90 days to review, but the whole process typically takes about a year, in my experience, to achieve a 510K if you've done everything correctly. The PMA process, class 3 devices, I mentioned, this takes typically a minimum of 36 months, and this is where a pivotal trial might come in. This is U.S. medical device approvals in the United States. The taller green bars are 510K clearances. You can see 510K clearances are a little bit down in 2019, and you can see there were 2,800 of them. The PMA process shown by the yellow line, that's a little bit different. You can see that in 2019, there were about 30, and they were projecting a slight downturn. And these numbers don't follow all the way through 2020, although we're expecting a little bit of a downturn due to COVID. But the clinical trial itself can cost anywhere from $30,000 to $50,000 per patient, which was a real education for me. You want an endpoint that covers both safety and efficacy. It's expensive because you have core labs and clinical events committees. You have to do site management. You have to audit every site. And typically these are approval studies. Sometimes they're expanded to be larger to get more data. Anyways, it's like a game of operation. If you ever played that game where you reach in to grab the Adam's apple or the broken heart, if you just touch the side very gently, the electricity goes off and it makes a sort of a gong sound. In any event, these are a little bit older numbers. They haven't really been. It's interesting that this type of information isn't more widely available, but from concept to approval for a 510K pathway, the average a few years ago was 31 million, and for PMA process, 94 million. My own experience with PMA process is that it's more, and recently was involved in something that took about 120, I think, something like that. In any event, the point is it can take a lot. So the average time for a device to get through the PMA process from concept to approval is 8.6 years. So that's just approval. We're not talking about commercialization, which of course it takes time. Even if you have the most amazing thing ever, it takes time for that amazing thing to get out into the public and for people to get experience with it and understand whether it works. So the regulatory path, just to reiterate, there are basically no first-in-human studies in the US, so it means going outside the US, which means that is a bit of an adventure at times. A minimum of 2 to 3 year lag between US and EU, often more. Drug-coated balloons were available 8 years in the EU before the US. EVAR was available for 10 years before carotid stents, 10 years. Percutaneous aortic valve, 4 year, but when they were approved in the US, were accompanied by a post-market study of over 1,000 patients. So you can just see some of the differences there. The EU, however, is instituting a new MDR, medical device regulations, and nobody really knows what that looked like. It's been delayed by COVID, and it will be coming forward soon. So the acquisition by an established strategic is one way that your idea might see the light of day. There are other ways, a smaller company that's coming in to compete with the more established companies might be interested. Or now more recently, there have been some initial public offerings, at least in my area, Silk Road, Shockwave, and Inari, or a SPAC, a special purpose acquisition company, is the latest thing. And Butterfly, a handheld ultrasound, formed a SPAC and just went public recently. This is a thing where the company is formed specifically for the purpose of going public, and then it is merged with the medical device company or the company that people want to invest in. So what do strategics want, the big companies? Well, they want the device to be de-risked if possible. They don't want to take on extra risk if they don't have to. And this sort of puts them in a position where they don't want to be too early to the table. They want to have an acceptable design history file and quality controls. They want to have low manufacturing risk. And it has to be, I mentioned earlier, the cost of goods has to be acceptable. And then, of course, the strategics, they want to be able to leverage their sales force. They've put a lot of money and effort and time into having their sales force be well, sort of be the experts in their area, and they want to leverage that. They also might want a differentiated product. They may want something to compete with, other companies that they typically compete with who have something similar. Think about how many different companies offer an atherectomy device, for example. And of course, they're competing with each other. Or they may want your device because they want to kill it, because they think it's going to harm their existing business. And of course, you would hate to see that after working hard on something, but these are just some of the motivations of the strategics. And there are unforeseeable external circumstances. The dot-com bust, the 2008 financial crisis led to a dramatic decrease in the amount of money being invested in these so-called high-risk projects of developing a medical device. The Affordable Care Act included a device tax, which was a very depressing effect. And of course, lately we had paclitaxel, then COVID. So, and COVID has negatively impacted early stage venture capital funding as seen here, and hopefully it will bounce back. Going forward, lots of ideas will be funded, if you will. Anything that makes the cost of medical care less, chronic disease management, interesting uses for apps. Wearables and implantables are going to be a big one because they are existing technology, and we just have to figure out how to use them in a way that's going to help our patients. So, and you can kind of see the list there of things, at least that I think are probably going to go. So where do innovations come from? I just wanted to finish with this, that this guy, Graham Wallace, wrote in 1926, The Art of Thought. Of course, this was when the world was being supplied with electricity and electric lights. And he came up with this idea, illumination. And even today we say the light bulb goes on, and you thought of this idea. But a lot of ideas have been identified through pattern recognition. These are all, of course, famous physicians, Walter Reed and yellow fever, Fleming, and the invention of penicillin, and Watson and Crick. They all had some form of pattern recognition that helped them to understand what the next step would be. And of course, this is what we do every day in cardiac and vascular care, is we're looking for patterns. This is what makes us good clinicians. Looking for those same patterns can help you come up with maybe where your idea is going to come from. So, and then lastly, I'll just recommend this book from Stephen Johnson. He's wrote several excellent books, but this one is Innovations and Where Do They Come From? And you can just see some different ideas, the adjacent possible. You can imagine transferring technology, the slow hunch. This, I think, is closest to this thing I'm talking about of pattern recognition, and you learn over time, and you get to the point where you can almost imagine what needs to happen next. Accidental, I think, happens, but I wouldn't wait for that. And of course, this so-called coffee house method, which is sort of like the slow hunch, because you're continuously bouncing ideas off your friends and having different experiences, whether it's in the OR or the cath lab or in other venues. And lastly, Albert Einstein, the secret to creativity is knowing how to hide your sources. So in conclusion, I'd say we have an obligation to innovate. We talked about assessing the unmet need, the developmental process, clinical trials, potential exits, and where do innovations come from. So with that, I will conclude, and I want to again thank you very much for inviting me to participate. This has been a real honor.
Well, Peter, thank you very much. I mean, it's succinct and logical in a way that only you can present. So I really appreciate that. That's a phenomenal blueprint. And it's actually created a lot of questions, more than I've seen actually when we're doing this. So I'm not sure I'm going to get through all of these, but let me kind of kick it off. From your experience, what is the best way to fail fast? To learn if an idea has merit or just does not solve the problem, or pathway to commercialization is just too onerous. So the question is about testing it and failing fast if it doesn't really work.
Yeah, so do you remember that where I was saying the best thing to do is to get to proof of concept for the least possible amount of money? And I could have said the least possible amount of time as well. And when I say proof of concept, what I mean is that you need to try to set up a simulation of the problem that you're trying to solve, and then see if you can solve it. If not on the benchtop, then in some other method. You may have to go directly to the animal lab. But if you can solve the problem, even with something that doesn't actually even look like your device, but you can see that the problem is solvable, and you can do that for inexpensively and quickly, that's the thing to do. And I know I'm being oblique here, but I'll just give you an example. So one of the projects I worked on is a serration angioplasty balloon. That's a freestanding company. I consult to them. And the first thing we did was go into the cadaver lab. We got some arteries. We made a series of serrations. We didn't have a device that did that. We just did it by hand, and then put the artery into a tensionometer and applied tension to see, does the artery open along the serration or not? And that may be a kind of it sounds like something you would do kind of in your garage, and honestly, I've had cadaver arteries in my freezer in the back of my house, and I probably broke some rules. I don't know. Luckily, there are none in there now. My wife is relieved to know. But I'll just say it is a little bit like a project in your garage at first. And the more you could do in your garage to convince yourself this is worth pursuing, the better.
Well, that's fascinating. You don't always succeed in the projects you're taking on. I'll show you an example of where you failed fast. Is when you tried to teach me how to surf, in Honolulu one day. That was probably a bad concept, yeah. But we failed pretty rapidly. So are there any recommended conferences to attend for ideas, networking, and pitching ideas? How do you network in this business?
Yeah, that's a really good question. I think, the folks that I have met has been mostly by asking questions. So every conference that we go to as clinicians is typically attended by people who've gone down this pathway. So I've introduced myself and now have some amazing friends that are just people I walked up to and say, hey, what would you do with this? And it's always surprising to me how people want to share. The other one that you might think about, for example, pumps and pipes. I attended virtually this year. That's fantastic because you're talking about ways of transferring existing technologies into our field. Another one is every January they have the JP Morgan conference in San Francisco. This year was virtual. It's an invite-only thing. Of course, I'm not invited. Most people aren't. But there's so many parallel activities associated with it where entrepreneurs are there either looking for funding or looking for people to work with them. And lastly, I've never worked at the Stanford Biodesign Center, but I've known a couple of people who've been through that. And you might just look at their literature and look at what they put out, because they put out a tremendous amount of interesting things because they're thinking through this process every day.
Well, thanks, Peter. We actually have I guess you call it a chapter of biodesign here in Texas Medical Center. And we recently just started a new medical school called NMed. You got to be an engineer, you got to be an innovator, and it's kind of one of these boutique type medical schools. And I suspect that some of these questions that I'm going to ask you are coming from some of our NMed students. So one of them is just getting into medicine and engineering. Is there more of a need for software or hardware in the vascular field? Is that something you want to tackle?
Well, I mean, that is an unanswerable question, but it's the right question. And the reason why I say that is because we truly are transitioning. So I didn't have time to go through my whole list, but you probably saw at the bottom of it was this two little initials, AI. I really, and I went into length about how our work is pattern recognition. Well, AI is pattern recognition, and it's making decisions faster and with probably fewer mistakes than humans can make. And the question is, how will that be applied? That is a super exciting area. If you think of digital health, and you think of, it may be that, so I'm involved right now in a oversight or assistance with a pulmonary embolus study that where the patient afterward has a wearable where their activity is tracked by this wearable, and how much activity they do actually might be the difference on the outcome of the study, on whether they return to normal life or not. Regardless of what people say, their activity is it won't it'll be more accurate. And so this is an area where if you apply AI to that, for example, to that wearable, that's a place where your computer is going to beat your sort of hardware, your catheters and devices every time.
So you've kind of tiptoed into one of the other questions, and that was mobile applications. So you talked about one of the PE. Anything else you've seen that's exciting?
Yeah, so I know a guy at Stanford, a guy named Oliver Alami, who I've seen him present his idea. He's got an app that tracks claudication. I've also heard I've heard a snippet from insurance executives that are saying that actually mobility is more important than any other single factor in deciding a person's, what their overall health level is. So that just gives you some ideas about, how I think these things are going to make a huge impact in our lives.
The last question, pretty specific. there any role for blockchain technology in the future of medicine? Do you know anything about blockchains?
No, I got to get one of my 20 and 30 somethings on the phone and get a phone a friend to help answer that question.
Well, that's a great answer, Peter. This has been very entertaining, very educational. Thank you very much. I'm not sure if you're going to work or going back to bed, but appreciate you putting yourself out to join us this morning.
I would say there's always work to do, and I got to say that even though you didn't pick up surfing that quickly, your son picked up surfing quicker than anybody else I've ever seen, and I've taught, oh my goodness, dozens of people at various times. So congrats on that.
Well, thank you very much, Peter. Appreciate it, and best to you and your family. Bye-bye.